Alright, so today's lesson we're going to be looking at the unit circle and the coordinates of the unit circle. And that is going to combine not only our information and knowledge that we know about it, but also two very significant triangles, which we use the terms of special right triangles for. And so with that we have the right triangle that has a 45, 45, 90, and the right triangle of 30, 60, 90. And so for the triangles, you'll notice that they came up with basically a pattern or a formula of the relationship between the sides for every single 45, 45, 90 triangle will always have this exact same relationship. As well, every 30, 60, 90 triangle also will have this relationship. So what that means is that if you know any one side of either one of these triangles, you can find the other two sides. So we're going to use that information to see how it applies to the construction of a unit circle. We're going to start off with some basic examples just to kind of notice the pattern and understand what's going on with the combination between the special right triangles and the unit circle. So let's say that we have a right triangle, 45, 45, 90, and technically it's going to have the line segment or radius in terms of a unit circle of 3. So obviously when I take that 3 radius and start tilting it around what would become our unit circle, you'll notice that obviously it's not going to land at any perfect number in between here and here. So we need to find and do a little bit of math to figure out what these other two sides are so we can find our coordinate. So given that our line segment, our hypotenuse, is 3, what that means is that 3, make sure I'm on the right layer here, 3 is equal to x square root 2. So in order to figure out what x equals, one way you can do this is basically divide both sides by 2. These will simplify and you'll get 3 over, and let's actually replace this. Let's do x equals 3 over square root 2. Obviously we don't want to have a square root in the denominator, so we're going to rationalize our denominator. This will simplify out to 2. This becomes my value of x, which was 3 square root 2. So this is actually what x equals. That also means that's what the x equaled over here. So if I was to go and get my calculator, let's say what is this actual decimal value, and do 3 times square root 2 divided by 2. And so what we get is 2.1 initially. So I'm like, okay, well fine. That means that this side is 2.1 and this side is also 2.1, since we know that both of these are the same length. So that means I can, to find this point here on my triangle, I'm going to go over, and I can even actually zoom in a little bit. I can go over 2.1 and go up 2.1 and plot my point. This coordinate here is 3 square root 2 over 2, comma, 3 square root 2 over 2. And that means the distance from here to here is 3 units long. So this can kind of be a concept of rotating this radius along this line at this dimensions. And that would be my ordered pair. Okay? So what if we had a triangle that had a radius of 2? So we're saying, okay, it had a line segment of 2. I want to take this 2 line, and again, I want to pivot it and see what I get. And so what am I going to do? I'm going to do the exact same thing. I'm going to take that 2 equals x square root 2. Again, that's what this line segment is. That's what that is. I'm going to divide both sides by square root 2. Simplify, and I get x equals 2 over square root 2. Rationalize the denominator, and I get 2 square root 2 over 2. So if I go to my calculator, 2 times square root 2 divided by 2, I get basically 1.4. That means both of these sides are 1.4. So again, I can come to my circle or my graph and go 1, 1, 2, 3, 4. So that's my x, and up 1 and 1, 2, 3, 4. There's my y, which would be my sine, basically, my cosine and my sine. And plot my point, connect my line. This line segment is now 2 units long. It is the same distance and has the radius, oops, got a little off there, as my 2. And my coordinates would be my cosine, technical distance, or my x, which we said was 2 square root 2 over 2, and my sine, or my y, which is 2 square root 2 over 2. And that's my ordered pair. So hopefully you're starting to see a pattern here, because that is significant. So let's remove this and see. Now let's come to the concept of our actual unit circle, because the unit circle says here's a circle that happens within the unit, single unit, or aka 1. When my radius is 1, that's all a unit circle is what's happening here at one of my smallest, really fundamental units. Okay, so I'm going to do the exact same thing. So x square root 2 equals 1. 1 equals x square root 2. Divide both sides by 2, or square root 2. And I get that answer there. I'm going to multiply, rationalize my denominator, and I get square root 2 over 2. And that now is my side length, and also going to be my coordinate. So radical 2 divided by 2 is basically 0.7. So over 1, 2, 3, 4, 5, 6, oops, what we got? It's going to be perfect. We're going to do our numbers here. 4, 5, 6, and oh, it's a little off. Okay, it's all right. So we're going to basically do a little bit of estimating here and here, and going to come to basically there. So now we are functioning within the unit circle. This has a radius of 1, right? And now this is where the coordinate point comes from. My cosine, or my x, and my y land me at radical 2, 2. Radical 2, 2 at the 45-degree part of our unit circle. That's the coordinate. So with that, if I come over here and I do basically the exact same thing, and to say, okay, well, what if my unit circle goes this way at, again, what initially would be a 45-degree angle? Well, my x has changed from positive x to a negative x, so this then is negative square root 2 over 2. And my y is still positive because it's just a reflection across the y-axis. And this would be 2 square root 2. And that's that value there. So it's like, okay, what if I come down here and extend it out? Oops. That's my line there a little bit. This way. And this is a 45 and a 45. What if I extend it out this way? Okay. And so then this coordinate now on our graph, this is our negative 1. This is negative 1, is a negative square root 2 over 2. And a negative square root 2 over 2. And just like any other coordinate, and if I come over here, my x is now positive, but my y is negative, so it's going to be a positive cosine, square root 2 over 2, but I'm going to down a negative sign, so negative square root 2 over 2. So that's the concept, that's the construction and where it comes from of our unit circle. Oops, I'm not doing so well going against my left hand. Of finding the coordinates at a 45, 45 for that component. All right. So that is our sign. So the question is then becomes, what if we end up doing something with the 60-30? The 60-30 is going to follow the exact same formula and concept. We have, let's just say 3. And we go, okay, well, we're coming now here. Well, this says that my hypotenuse, if my radius is 3, if I pivot that up 60 degrees in this situation, we are trying to find where it lands and what its coordinate is. So we're going to use this formula here on our triangle. So 2, oops, let's get a little bit thicker pencil here. 2x equals 3. Okay? Divide both sides by 2. So x equals 3/2. So that's what this length here equals, is 3/2. That's my x. Now the question comes, what happens when I go to find my y? Or yes, my y on this one. So this is going to be 3/2 x times radical 3, or 3/2 radical 3. That's this length here. Because that's all this says, is you take whatever quantity this length is, multiply it by the radical 3, and you get your answer. So 3 times radical 3 equals divided by 2 is basically 2.6. Okay, and this is 3/2, so 1.5. So we're going to basically go 1.5 and 2.6. And this point here then, oops, is a 60-degree angle. It has the radius or the hypotenuse, same thing because we're taking that radius and pivoting it around to create a right triangle within my unit circle, but in this case it is basically a 3-unit circle. And my coordinates are going to be my cosine, or my x, 3/2, and my y is going to be 3 square root 3 over 2. And that's its coordinate. And again, you can see how we basically were pivoting this circle. Okay, there we go, a little smooth rounder. And at the same time, bringing this down and constructing a right triangle. Okay, and obviously my freehand's a little on the rough side. And that's that. We could do the same thing with 2, but let's go ahead and skip down to the unit circle. And so, again, I'm going to do the same concept. I have my value here, and you can do it again with 2 and find it on 2 of what it looks like. But let's come here. So we have 2x equals 1. This is my length here. That's my hypotenuse. Divide by 2, divide by 2. So x equals 1/2. So this is 1/2. That's my coordinate of my x value. That's what's going to go here for this point when we plot it up here. Okay, so we know 1/2. So now I'm going to take 1/2 and times it by, well, at least times it by radical 3. And you can put this over 1 if you want. And basically what you get is radical 3 over 1, or just radical 3. Oh, excuse me, over 2 times. There we go. I say, that's all right. So that is my y, or my height of this triangle. So if I go to plot this on now our unit, so again, a unit means we're zooming all the way into here, and everything we're doing is existing within this 1 unit circle, literally a circle. So let's see if, oh no, this isn't going to work very well. There we go. Close enough. So there's our unit circle. A little rough, but it'll work for us. So let's see here. We had radical 3 divided by 2 is basically 0.8. Oh, and that's our y. 0.86. Okay. And our other side is 1/2. About half and up, and that'd be about right. So if you can imagine putting our triangle in here, and this is 60 degrees, 90 and 30, then my coordinate is going to be the 1/2 radical 3 over 2. And that's my y, and that's my x. So, and again, and if I was to take this value and basically flip it, and obviously I extended this side out as a little bit extra. So we'll just go about there. And I extend this 60 degrees in each direction. Now note my x has switched to a negative, so it's negative 1/2 radical 3 over 2. Okay. Down here, look at this. Oops, that's not pleasant. Right, and so for this one here, we'd have negative 1/2 and negative radical 3 over 2. And then if we extend it this way, line's a little off, that's alright. My x is positive and my y is negative. So all we did is found a 30, 60, 90 triangle with a hypotenuse of 1, because that's our unit radius, and found its coordinate on a graph. And then we took that and flipped it, and flipped it, okay? Or reflected it, and plotted its coordinate. So this also comes into play when it comes with working with the 30 though. Because with the 30 triangle and our 30-degree angle, basically says, okay, I'm going to cut this in half. And now this is a 60, 30, 90. And it says, well, what would the coordinate here be? Well, all I did is I took the exact same triangle and I literally flipped it. What once was my x has become now my y, so radical 3 over 2. And what once was my y, or my sine, has become my cosine, or my x, which would be 1/2. So then I can take this exact same measurement and coordinate, and again, plot it all throughout. I'm going to do it in here for this one. So what once was positive will be negative x, okay, and etc., etc., etc. And that's how they get the coordinates on the 30, 60, 90 triangles. And so they're all just going to be flipped. So radical 3 over 2 and 1/2. And they're both going to be negative. And I'm going to do the same thing over here. And for this is going to then be radical 3 over 2 and 1/2, but my y is negative. So once you take your 30, 60, 90 triangle, your 60, 30, 90 triangle, and you also combine it with your 45, that's when you start getting the different components of your triangle. And you get the coordinates of your unit triangle. Everything up and put it on our unit circle. Again, unit just means 1. And find these coordinate points of the 30, 60, 90 triangle, the 45, 45, 90 triangle, and the 60, 30, 90 triangle. then these are the coordinates that you get for these points here along the actual circle itself. And then you just take those and you can reflect them across the y-axis, obviously making the x values negative, reflect them again, making both values negative. Over here, they're basically negative x, positive y. And then if you flip them or reflect them again down here, then you would have your positive x and your y value would be negative, and thus gives you all the coordinates for the unit circle. And that's where they come from. All right. Well, I hope this helped, and have a great day.